Cool. Okay, so once again, welcome to the first workshop for the N2E Robotics Club. Um, Let me share the collab with you guys. I'm going to be sharing my screen so that you can kind of see what I'm talking about and follow along. But the link I posted in the chat is so that you guys can get kind of your own copy of the code and you can log on to Google Colab and play with it and change some things. And also just kind of add it to your drives and keep it if you think that would be useful for you. So cool. All right. So can everyone see the screen? I assume so. Awesome. Okay, so this is Google Colab. It's basically a free tool provided by Google that lets us use all of their computing power so that you don't have to kill your computer by doing compute-heavy programming. So it basically has all of the normal, I guess, kind of interface things that you want. You can put code in here. You can put text in here as well. And like you can make new blocks by adding new code blocks, new text blocks, etc. And one of the cool things, let me just get rid of these really fast. Okay. One of the other cool things is that it gives you access to GPUs. So I'm just running this on like my regular Mac. But if I wanted to, let's say, do some machine learning that required a GPU, you can go to runtime, change runtime type, and then add a hardware accelerator. So then you just have access to it and can use it. It's mostly free, but I think, of course, there's like memory limits. And then I think the GPU runtimes also have a time limit where they log you out. And then they have cool, fun things like cats that can run across the top. So that's Google Colab. But getting more into this workshop, I'm going to be talking about different environments that you can use in Python with OpenAI Gym. But one of the things I thought I'd have to talk about first is reinforcement learning, because that's really what the environments are used for. And I didn't want to just assume that you guys had experience with that. So I'm going to do like a really high level overview of it right now. And then maybe sometime in the future, I can do another module about reinforcement learning itself. So basically with reinforcement learning, this little graphic is all you need to know. There's some agent in the environment that's going to be making decisions. What it does is it takes in its observation about the current state. And this observation could really be anything. If I am the agent, like as a person, my observation is what I'm seeing. So it could be an image. It could be like a list of locations. It really just depends on what type of application that you want to do. But based on this state and observation that you're seeing of the environment, you're going to take an action. And so that action gets sent to the environment. And the goal of the agent is to try to get the highest reward. So the environment's going to see what state you're in. It's going to see what action you're trying to take. And then it's going to say, okay, this reward that I'm giving you tells you how good your action was at accomplishing some task. Now, again, it kind of depends on what application you're trying to do, but let's say you have an agent that's just trying to get from point A to point B, and it's like along a straight line. You can think the observation would be just kind of an image of where it is in the environment. Its action could be, I'm going to decide to turn right. And then if we know that it's just trying to go straight, but instead it decided to turn right, then the environment would give it like a very low reward because it's trying to tell it, hey, this action of turning right was very bad. But if the agent decided to then go straight, then it would give it a really high reward because its action is bringing it one step closer to achieving its goal. Let's see. And then I have like a whole write-up here that I'm not really going to read because I've given you guys a link to the collab, which also I'll send out after this, just in case you guys don't end up having it. Let's see, what else? So I guess there's a lot of work in reinforcement learning about kind of what type of reward to give your agent. So there's like positive reinforcement or negative reinforcement types of things. But the overall goal of the agent is to learn a policy over states and actions that gives it the highest amount of reward in the environment. So I guess I kind of went over that really quickly. If you guys have any questions, feel free to just unmute and interrupt me at any time. So I guess, are there any questions about that? And then I can check the chat too. Maybe I can check the chat. It might not let me check the chat. Okay, cool. If somebody asked the question in chat, also feel free to just like interrupt me, someone. But okay, so I guess now we can get into the OpenAI gym. So this is basically a platform that provides a lot of really useful environments for reinforcement learning. So like kind of how we were talking about, it will supply the state observations to the agent, and then it will also take in an action from the agent and then give it a corresponding reward. So the first thing that we have to do is install some dependencies, because if you're just trying to run this on your own computer, you're not going to have anything installed. So the way that you run code in Colab is you make a new code cell block, you type it in, and then you click this play button, and it'll like run each cell. So the language that I have chosen is Python, but if you do the exclamation point in front of whatever line of code you're trying to run, it'll run bash commands instead. So I'm assuming all of the backends here are Linux as well. So all I'm doing with this is installing the gym package. So pip is just the Python package installer. And then just some other useful packages that will help us display the environment, because Colab does a couple weird things with how it displays graphics when compared to like your normal computer. And then when we're installing OpenAI Gym, you can install the whole thing with pip install gym, or you can install like a specific set of environments by doing these three commands, like so Atari or Box2D or Classic Control. Let me actually see if I can show you guys OpenAI Gym. Cool. So I have a link to this somewhere in the collab later, but this is the website for OpenAI Gym. And so like you can see, there's a whole bunch of different sets of environments. So if you're going to do pip install Atari, it would install all the code that you need in order to run like some Atari games. I've never actually played Atari, so I don't really know what most of these do, but Brick Breaker. Okay, that looks familiar. But it'll run all the code for doing like those types of things. Or if you do the Box2D, they have, I guess, this bipedal walker or a lunar lander or car racing and things like that. Okay, so these commands should run no problem. And then we're also going to import some relevant packages. So this just has to do with how we're going to display it in Colab. Importing gym imports the OpenAI gym package, which is what we're going to need to run the environments. Gym logger and gym monitor is just how we're going to record what's happening in the environment in order to like make a couple of videos so we can see what's going on a little bit later. Matplotlib is a package in Python that just lets you make plots of simple things. This matplotlib inline is required for plotting in Colab specifically. And then these are just a couple other helper functions. Okay, So now what we're gonna do is look at a couple different gym environments and kind of just see what they look like. So I have some instructions here, but the typical way that you do it is by importing gym, right? And so this first line I have prints out all of the different environment names. So let's see if we can look at that. Ooh, I can't scroll down. Okay, so like M-spec, repeat copy, or reverse edition, or cart pole, mountain car, pendulum, those types of things. Um, and so the way that you initialize a gym environment is by doing this gym.make, and then you can take any of these names that we printed out in the previous step, put it in here, and then just name it something. So end equals gym.make space invaders, and then that initializes your environment. This end.reset resets all of the variables to in the environment to basically what they would have been if you hadn't taken any actions in it yet. And then I'm just using this line, the plt.imshow, to plot the environment. And then this env.render just gives you an image of the current environment state. So I've done this for Space Invaders, Cart Pole, Mountain Car, and Pendulum. So you can see this is the Space Invaders game here. Um, then we have, what's the second one? Cart Pole here. So I guess the point of Space Invaders is you are a little person on the ground and you're trying to shoot all the Space Invaders before they reach the ground. Cart Pole is you get to move this black box here so that you keep the pendulum straight up and down because it's going to fall with gravity. So you're kind of trying to always stay underneath it to keep it up. And then mountain car is you're trying to learn how to accelerate the car to get it up to the flag, but not past the flag. And then the last one was called pendulum. And then it's kind of like the cart pole. We're trying to figure out how hard you need to rotate the pendulum in order to get it to stick straight up and down in the environment. And there's a whole bunch of other ones you can use. Let me actually go to, oh, did I still have it open? I did. Okay, so let me actually go to here. So then there's some classic controls. Here's where we got the cart pole and the mountain car from, and you can see some GIFs of them moving. So like the pole will kind of move over or start to fall over. And also with the pendulum. The Mujoko ones are pretty cool, except it requires that you get an outside license in order to run these, because you have to download the Mujoko package, which is basically just like a physics engine. I think it's free for students, but I haven't actually done it myself. So that could be something you could look into. But they have some cool movement type things. You can learn to be a worm and things like that. And they also have a robotics package, so you could learn how to pick up things or manipulate a hand and things like that. Okay, so we've displayed some different environments. That's cool. But how do we actually take actions in the environment? For that, we kind of need an agent, but since this isn't about reinforcement learning, this is just about the environments, I've just kind of made an agent that takes a random action in the environment for now. So we're not going to see the agent really succeed at any goals in this scenario. We're just going to see it kind of move around to demonstrate how the environments work. So, okay. This show video and this wrap env function is just a helper function to create the videos that I'm going to show of the different environments. But basically what we're doing is, ooh, that moved, making the environment. So we're going to demonstrate this in Space Invaders. And then env.reset resets all of the variables to make it as if you haven't taken any steps or any actions in the environment, and it returns the first observation that the agent will see. And then what I've done here is printed out the action space dimension, which is this discrete 6 here. So the way that they're representing actions in the environment is as individual integers, so 0, 1, 2, 3, 4, or 5, and they correspond to different actions like moving left, moving right, shooting, doing nothing. If you want to look up, or if you want to see exactly which number corresponds to which action, you'd have to go on the OpenAI Gym website and look at the actual documentation, and they'll tell you which action does what. So basically what we've done is we get our observation, and then this is just a loop so that it'll do this section a couple times. But we render the environment so that we get to see it. And then we pick a random action. So env.action space will give you a list of all of the actions that the agent can take. And then if you do .sample, that will choose a random one from that list. So now action is just a random action. And then if you do env.step, that is the function that you use in order to tell the environment, hey, the agent would like to take this action. And it will go, okay, cool. So then it will propagate any changes to the environment based on that action and return you a new observation. And then we'll also look at those changes in the environment and what action you chose and give you a reward. And then it'll also tell you whether or not you've achieved your goal. So that's going to be like a Boolean variable, so either true or false. And then any information that also might be useful about the environment. Again, what exactly is going to be returned in that variable, you'd have to look into the documentation for whatever environment you're trying to use and see specifically what they say about that. But then this just checks if we notice that we are done with achieving the goal, which in Space Invaders happens if you win or if you lose all your lives and die, then it just breaks out of the loop so that it stops. This env.close and show video just kind of populates this video down here. So you can see it starts at the beginning and it's not doing anything smart because it's really mostly just getting shot at and shooting the barrier that's protecting it from the aliens. But even as a random agent, you can see it got rid of a whole row of aliens. So it still kind of does pretty well, which is a little bit surprising. So that's an example with Space Invaders. And then I also did the same thing with this brick breaker environment where you initialize the environment with gym.make, and then you reset all the variables in the environment, which also gives you the first observation, and then you render it so we can see it, pick a random action, and then do env.step to tell the environment that you want to take a specific action, and it returns all of the things you need in order to train your agent. And so you can see here, it's making random actions, not really bouncing the ball back, and the video ends because the agent loses all its lives and it dies. So all of these are pretty cool if you want to train an agent to play a game or do something kind of trivial. It'll be a good foray into reinforcement learning. But what if you want to train it to do something else or something more concrete? So what you can do is make your own OpenAI Gym environment. And the main things that you'll need to do this are to define an init function, a step function, the reset function, the render function, and then the reward function. So I thought the simplest way to kind of show this to you guys was to make my own. So I just chose a stock market environment because it seemed like the simplest thing to render in this shortest amount of time. So the experiment that I've devised is you have an agent who is starting off with $100 and no stocks. It's just trading on the S&P 500, so it's only really focused on one stock. And its goal is to make $500, and that's when the experiment will end. It has 3 actions. So buying a stock, selling a stock, or doing nothing, which are represented here by buying is 0, selling is 1, and doing nothing is 2. And so I guess we can just kind of go through this. So this pip install data package is just what I had to install in order to get the data to use in the environment. But what we want to do is import gym. I'm going to do some plotting, so I imported matplotlib. Pandas is an environment that lets you work with CSVs or Excel sheets really well in Python. And then NumPy just kind of helps you with, I guess, data processing. And then, yeah, the others aren't really important. Okay, so the first thing you want to do is instantiate your class and then extend this gym.env, which will get you a lot of helper functions from like the standard gym environment. But the first function you want to make is this init function. And so what you really want to do here is load in all of your data and set all of your environment variables. So what I'm doing here is just downloading the stock prices. So if you wanted to make some other environment, you would load in your data there. And then I just kind of set all of the stock prices in a list as self.states. And so I've downloaded stock prices for something like 5 years, let's say. And then also what you want to do is define your action space. So that for that you have to do from gym import spaces, and then you just set it to the number of actions that you want your agent to be able to take right there. So then the next important function is the reset function. For this, you really just want to be able to reset any state variables that you defined in initialization, or just any other variables that you have that are like helper variables for accessing your data. So for me, I added a couple. So this self.stockInd is keeping track of whatever the next index is for the states. Then I have this portfolio value, which is keeping track of how much cash the agent currently has. And then the stock shares, which is keeping track of how many stock shares the agent has. And then the thing you want to make sure is that your reset function returns whatever the first observation would be for your environment. The render function is really simple and also really application specific. So I'm just kind of gloss over this, but it basically just plots whatever observation your environment would be returning. Okay, so I think the most important, or I guess the top two important, but the first of the top two important functions is the step function, which is what's actually going to be propagating the changes due to the agent's chosen action through the environment. So it has to take in an action, obviously. You can choose it to take in some other things if you think it's important. Again, it kind of just depends on what application you're doing. But for the stock, we only needed the action. So like we showed up here, the step function returns an observation, a reward, whether or not you have finished whatever task you set out to accomplish, and then any other relevant information. So here I've just set done to false at the beginning, and then I check some conditions later to try to set it to true if we have actually finished. And then I just arbitrarily set the reward to 0. So the first thing I do is find the next observation, which is going to be the next price for the stock. Then I check to see what exactly the action is that the agent wants to take. If it's 0, that means that they want to buy a stock. So you have to check to make sure, A, that the agent is able to take that action, and then B, you have to propagate the changes through to the environment. So first I check to see if you have enough money to even buy the stock that you want to do. And if you do, then I increase the stock shares, because that's what happens when you buy a stock. And then I subtract the amount of cash from the portfolio value that's equal to the stock price. If the agent tries to buy a stock but doesn't have enough money, then I set the reward to -1 because you want to give the agent a negative reward for doing actions that are really bad. So then if the action instead of buy is 1, which would be sell, then we want to check to make sure that you have enough stocks to be able to sell a share. In which case, then I just subtract 1 from the total number of shares and add the amount of cash back to the portfolio value. But if you don't have any shares and you're trying to sell a stock, then I give a reward of -1 because you really want to discourage the agent from taking that action in the future. And then this else pass captures if the action is 2, which would be just to do nothing and sit with whatever stocks and money you have. But also it captures whether or not the agent tries to take an invalid action, like say it gave me like 4, which isn't 0, 1, or 2, or if it gave me -337, it would still do nothing. So depending on, I guess, what agent you're using and what your application is, you might want to either like stop the entire program and say, hey, you've given me an action that's invalid, or you might want to give it a really, really negative reward because you're like, this action doesn't even make any sense. So it kind of just depends on what your application domain is, what you want to do there. So now that I've propagated any changes into the environment based on what action the agent wants to take, I then want to look at the action and the current state and then try to give the agent a reward. So if the reward is 0 still, like I set it to up here, it means that the agent didn't, try to buy when it didn't have enough money or sell when it didn't have any stocks, which means then I just call the reward function and I give it the current action that the agent was trying to take. And I'll go through specifically how I'm defining the reward in a little bit. But then you get the reward based on that action. And then I increment the variable that's keeping track of what the next stock price that the agent hasn't seen yet is. And then I check to see whether or not the agent has accomplished its task. So that would be if it runs out of stock prices. So if it goes through all 5 years worth of stock prices and still doesn't double its money, I just arbitrarily end the experiment and say you've had enough chances. Or you check to see if the amount of cash that the agent has plus like the value of their assets, so the stock shares times the stock prices, is greater than $500, in which case then you set done to true. And then you return the next observation, the reward, and whether or not the agent is done with its task. And so that's the step function. And then going back to this line where we compute the reward, you do that in the last function that you have to define, which is the reward function. And so what you want to put here kind of depends. There's a lot of debate on exactly what the best way to write a reward function is. It's a very common convention to have rewards always be negative. And so if you do a really, really bad action, you get like a really, really large negative number, so like -1,000,000. And then if you do a good action, you still get a negative number, but it's like -0.5. And so the agent will kind of treat this almost the same as if it got a negative reward, like -1, when it was doing poorly, or a positive reward of 1 when it's doing well, because it's really just trying to maximize its rewards. And this just means, get the highest number possible, even if that highest number is still really low. But for this particular application, I just decided to give it a reward of -1 if it does really bad, and then I'm going to give it a reward of 1 if it does well. And so I'm going to preface this by saying I don't know a lot about stocks, but in my mind, if the price goes up and you decided to buy more stocks the previous step, or you decided to do nothing, then you should get a good reward because that means overall your portfolio value is going to go up. So what I do is I calculate the difference in the current stock price and the future stock price. And then I just check, if it went up and you bought a stock the previous step or you did nothing, then return one. Um, or if the price went down between this step and the next step and you decided to sell, then that would be good because you got more value out of it. So then I return a one as well. And then in the other two cases, so if the price goes up and you decided to sell, or if the price goes down and you decided to buy, then I give a negative reward. And that's kind of it for how I've decided to design this environment. But the basic things are a init function where you set all of your environment variables and load all of your data. The reset function where you set all of your environment variables back to whatever they were at the beginning before the agent had taken any actions in the environment. Render, where you just, return like a visual of what your environment would look like. If you are dealing with an environment that doesn't really have a visual representation, you can really just ignore that one altogether. The step function, where you take in the action and you decide whether or not the action can be taken. If it can be taken, you propagate the changes through the environment. You figure out what the next observation will be for your agent, and you figure out what the reward will be for the agent based on its previous state and the action it chose. And then you figure out also whether or not the agent has completed whatever task you set out for it to take, and you return the observation, whether or not, or whatever the reward is, and then whether or not it's completed the task. You can also return some other pertinent information if you so choose, but for the stock data, I figured that this would be fine. And then also the reward function, where you tell the agent how good or bad its action in the previous step was. I guess if you want to get really fancy, you don't need to make your own separate reward function. You could just compute it in the step function, but it's cleaner this way, just so you can kind of keep it a little bit separate. Okay, so let's play that cell. Also, as another tip for Colab, if you are like just writing like a definition for a function or a class and you put it in a cell, and then in a different cell, you're going to use some code that's going to use that, you have to run the cell with just the class definition in it, or else Google Colab won't be able to find it. And it'll go, this thing that you're looking for doesn't exist. Okay, so now that we've made our custom environment, now we are going to test it and see how it works. I'm just going to give the, I guess, warning now that I couldn't figure out how to make the videos for the custom environment, so I just kind of record the actions and plot them all at the end, because I figured that would be fine. So what is this code doing? Here we are initializing the environment. We don't have to do gym.make here when we initialize our environment because it's our own custom environment and we're not using one of the pre-made OpenAI gym environments. So then we do m.reset to get the first observation and also reset all the environment variables back to before the agent had taken any actions. I arbitrarily set done to false here just because I made my loop while not done. And if I didn't, then done wouldn't have been defined and it would have broken. And then these four are just lists that I'm using to keep track of the actions and the states so that I can plot them later. But basically what we're doing is I have the agent here is just randomly taking an action. So the action space here refers to this line here. Ooh, no. this line here, self.action space, we called spaces.discrete with 3, and it will pick a random number between 0, 1, or 2. Then I'm just appending that to the list where I'm keeping track of whatever the actions were. Then we are doing env.step with that action so that we can propagate the effects of that action through to the whole environment, get the next observation, the reward for that action, and then the status of whether or not the agent has completed its task. And then I'm just saving those things so that I can plot them later. I'm also saving the current value of the agent's assets so that I can just kind of plot it so we can see what happens over time. And then this is all the code that I'm using to plot the results afterwards. So let's run it. It takes a little bit because it is not very smart. And so it's not really trading well, I guess. So the first thing I plot is the agent's actions over time. So this is the number of times it bought a stock, this is the number of times it sold a stock, and this is the number of times it did nothing. We just sampled it randomly, so all 3 bars should be about the same height. This is plotting just the general stock price over time. So we can see kind of how the price was fluctuating. So it started off really, really low and then skyrocketed. This is plotting the agent's portfolio value over time. And then this is plotting the number of stock shares that it has over time. So as you can see, it starts off with like no stock shares and its portfolio value is pretty low. Then it starts to buy some. And then you get kind of this spike here when it buys some, and also the stock price increases. But then it kind of sells them all back off. So then the portfolio value goes back down. And then it buys and buys and buys and buys and buys. So then you can see the portfolio value going up. And this is also corresponding to when the stock price is going up. So that tracks. If you have a lot of stocks and the stock price is going up, then your portfolio value is going to be high. And so, yeah, I didn't actually do anything with reinforcement learning. I have some sources on the bottom here for like where I got my code from, and just some other resources about where I got the data for the custom environment, or some things about reinforcement learning, or about creating your own custom environment in OpenAI Gym if there's some things that you're interested in that I didn't go over. But other than that, yeah, that's really all I have for you guys. So I guess at this time, are there any questions?
Not for me. I'm just observing.
I have a quick question.
Yeah.
So, like, so I understand that, like, based on the actions that the computer takes, it'll return like a positive or negative reward. But I'm kind of confused. What exactly does the computer do with the rewards?
Okay.
Like, does it learn from them somehow?
Yeah. So that is more on reinforcement learning where, okay, so I guess I should have done a module on reinforcement learning before I talked about the environments. But
I understand. I'm talking about like in your code specifically. Like,
so in my code specifically, it's not doing anything with them. So it's not actually
okay.
them. It's just taking random actions.
Oh, okay. But so like you could program it theoretically, be like so if it will always perform the action with the highest reward, like theoretically.
Right. So you could always program it so that it would look at the rewards it got in the past for taking specific actions and go, well, I always get a really low reward for buying and a really high reward for selling. So I think I'm going to try selling right now and see if that will lead to a higher reward in the future.
Okay.
Yeah.
Okay. That makes sense.
Question.
Yep.
I came actually a little late. So like with this OpenAI, so is this like a specific library that already came with this code, or like did you have to write it all?
So the OpenAI Gym is a package that you can install in Python, and they give you a whole bunch of libraries with environments that you can use for reinforcement learning. So it's like a whole Atari suite. You can play like Pac-Man and other Atari games I don't know the names of. That looks like bowling, Brick Breaker, and things like this. So they give you code, and I will send around an email with this Google Colab sheet. Did you fill out the Google form so that I have your email?
I don't even think I ever found out about a Google form.
Okay, so I'm gonna really quickly just send this Google form in the chat again. If you guys haven't filled it out, please do. Where is chat? There we go. Okay. So that way I have all of your information and I can send you guys updates about the rest of the workshops and stuff. But yeah, OpenAI Gym is a package that you can just install with Python. And it gives you code to, display these different environments, right? So if you do gym.make with the name of the environment, then it'll initialize it. Env.reset kind of resets all of the variables to back before the agent took any actions. Then env.render shows you an image of it. So I've kind of just plotted some here.
Oh, so it's kind of like you're telling it to do something and it's creating like a 2D or 3D simulation of that.
Right. So it has some simulation environments already coded. So then if you want to take an action in it, you just do end.step with that action. The action is some integer. So it tells you what the action space is. So I printed out here. So there's 6 actions in Space Invaders. So then this action here could be a number either 0, 1, 2, 3, 4, or 5. And then based on that action, it'll update the environment as if you were playing Space Invaders and you decided to do the thing, and then it'll give you a new observation, a reward that tells you how well your action did, or like how beneficial it was to your overall goal. For Space Invaders, your goal is defeat all the aliens, and then done would be whether or not you've actually completed the goal or not. And then, Atari is cool, but maybe not exactly what you want for your reinforcement learning environment. So then I just went over how you can make your own by making like a stock market environment here. And then it showed how you could, trade on the stock market, kind of.
Awesome. And then I guess like could a lot of this stuff also be integrated into real world projects as well? Like stuff I can do in Unity 3D or like some robotics stuff?
Definitely. So if you have a Unity environment, you can kind of make a class like this, but instead of loading data from a CSV file, you can like load stuff from Unity, and instead of step being change your portfolio value and the number of shares, it could be like actually executing the action in the Unity environment instead.
Oh,
Yeah.
thank you.
Yeah. Let's see. So I guess, are there any more questions? Or is there anything anyone wants me to go over again?
I do have one question.
Mhm.
If you have like this running on over and over again, you could repeat this to get it to learn from its previous.
Right.
Okay, that's the whole idea, really, right?
Yeah. So in theory, when I was testing my environment, I just had it go through this once, so once it says done, you're done. But if you're doing actual reinforcement learning, you could just say, cool, once I'm done, env.reset, everything's at the beginning, and now do it again. So you could just keep training your agent.
Yeah, that's cool.
Cool. So I guess if that's the end of the questions, if you have not filled out the Google form, please, please, please do so, so that I can send around the link to the Google Colab, and also just any other updates we might have for the rest of the workshops. But thank you guys so much for coming. Our next workshop will be next week, same time. And I think we're going to be doing an intro to ROS. Yeah, so we're going to be doing an intro to ROSlib.js, and then how to make your own ROS sensor from like an old cell phone that you might have lying around. So I think that'll be really cool. Great.
All right. Thank you. This really helped.
Yeah, cool. Thank you. I appreciate your time.
Yeah. Thank
Of course.
Thank you so much.
This is a wonderful presentation.
Thanks for coming.